Hello, my name is Rusty Oliver. We are at Hazard Factory cutting up some fire extinguishers, and the idea is to use these as targets for the tomb clone weapon. So we've got a really high quality steel that was free, of course, and I've got a wall thickness of 0.18. So we're going to take 5 or 6 of these, prep them this way, and then feed them into the tomb clone blade, and we'll be able to evaluate from the tachometer and then the actual impacts on the objects exactly how well this type of material will fare against that particular weapon.
All right, so last time we were just getting RPMs measured on the video that we were recording. So that's all good, but it's just there on the film. So what we've got now with this here is we're actually have a connection back over to the Arduino that's running the tachometers, and you can see we have the time code coming in here. This time code matches up with the time codes on the video, and once it starts rotating, we'll be able to graph the RPM, watch the instantaneous RPM, and then the big thing is we'll be able to record the data just like we do with the video, and then we'll save that off so we can match up the actual data that we're getting from the Arduino logged out, and we can match that up directly with the videos. So it should give us a much better representation of what the actual RPMs are when we get the hits.
So last week, when last time we did this, we sent a lawnmower into the blade, and I made the decision to attach the lawnmower directly to the steel by welding some arms in, and that went sort of well and sort of badly, but what it ended up doing was kind of yanking the sled into the blade, and then of course the blade completely destroyed the sled. So that's led to design revision. The rail here is very simple. There's just 2 pieces of angle iron supporting 2 wheels, and so if the sled gets destroyed again, we have less work to repair it, and this makes it a little bit easier to anchor things to the base plate. So what I'm not going to do without thinking about it, I guess, is to attach things to the sled such that the whole sled assembly gets pulled into the blade, because that went kind of not well. The other change that we've made is to insulate the sensing equipment a bit by running the conductors through the tubes. So we fully expect to lose a few more of these brackets, but these have been printed up so that they're more or less fungible. But the electrical connections are made in such a way that they're easy to repair and more insulated from impact. Looks very drunk. Just over 50 psi here. We're about to fire it. We've got some fire extinguisher bodies that are vented. They're completely open. They're just the shell, and we're going to feed those into the tomb clone. And we know that it's going to lurch a little bit. We just made a kind of improvised setup on the sled, so we'll see that all in the film in just a moment. It should also sound pretty great. Fire when ready. Those 4 cylinders.
All right,
Recording.
okay. I think we should go. Ready? 3, 2, 1. Oh, jeez.
Oh, did it pop a... So we just saw a pretty enormous impact. The cylinders have a lot of mass, so they hit the wall harder than other things that we've launched at it before. And I think we've actually got some significant repair work to do now. Let's see what happens. Oh yeah. that steel was pretty close to flat. It's definitely not now. And we lost some of our armor here. A lot happened in the short time of this event. Unfortunately, we did not have the GoPro, so we don't have the high quality slow motion. But let's go through the footage and break it down. In the lower left-hand corner, we're going to superimpose a moving graph showing the telemetry data, the RPMs from the optical tachometer. In the initial hit sequence, we can see a drop in RPM indicating an 8.4 kilojoule strike. This basically does all of the damage. About 5 seconds later, the RPM dropped all the way to 0, but the blade is still clearly moving. This is because the optical tachometer has been destroyed. You can see a fragment of it airborne in the video. At this point, we have lost all telemetry and the system is reporting all zeros. The video from the rear camera is a lot shorter because it almost immediately gets taken out by a flying fire extinguisher that gets hurled about 6 feet in the air and back over the structure. In the upper left corner of the frame, you can see it heading towards the camera. Lost some bracketry. Let's take a look at the cylinder. That's wild. Look at that. One passed through and there's a little bit of bluing from heat transfer. There's another one. Same thing, some bluing through the cut. It's about most of the way through the cylinder. Yeah, I can feel a indentation on the inside. This feels completely square except for a little, maybe a few. That might actually be something that's stuck to it rather than the blade. Yeah, I think that's some metal that kind of galled or smeared onto the edge. And that's the reverse of the blade. Front. This material is insane. You can see, owing to an indentation in the plywood camera mount and a gouge on the inside of the Lexan, that the fire extinguisher tried to actually come in through the side. So the bluing and the color that we're seeing in the steel, this is called interference oxidation, and the colors correspond to a given temperature range. So looking at this, we can actually look across the banding and see where it was least and most hot. And if I remember correctly, the innermost band, and this is really clear coloration, the innermost band, that would indicate about 700 degrees there where it hit. And we're not seeing any there, so it was like, you know, cooler, a bit hotter, hottest, and then, well actually that looks like hottest, and then at the exit, cooling again. Funny thing is it's smooth, it's almost like it was machined.
It was.
Yeah. I mean, I guess we have a secondary capability of milling things really quickly. Maybe not accurately, but very quickly.